What's up guys, welcome to the channel. This is Sonora Design and today is gonna be the best day ever because we're making a mass loaded transmission line speaker. Alright guys, so today we are gonna start a transmission line design. I started being curious about transmission line a few years back and I started reading about it and I thought it was so interesting and different kind of design. I've been working with closed like vented boxes, band pass boxes for automotive applications and stuff, and because as soon as I started like playing with full range drivers, I've seen a bunch of like back-loaded horns and transmission lines and I was always like, okay, how do I make that? So I started reading about it and getting familiar with the softwares and how do we make that. During my research on transmission lines, I met Neil through the channel. We end up like deciding to make this transmission line in a channel, as it's gonna be the first time I'm gonna build a transmission line. I have the Book of Magic here in my hands. This is Neil's manual, okay? It's available on his website and we're gonna talk about that later. Because you guys might be asking, okay, what a transmission line is, Dan? I know most of you guys might know what a transmission line is, but I'm gonna talk a little bit about it. A transmission line is basically a box with a maze inside, like long tubes that goes up and down all the way from the back of the cone of the speaker driver to the port, which is called the terminus. Basically what happens into this maze is that the sound that's generated from the back of the cone travels through this maze and come out through the port in phase with the sound that's coming from the front of the cone of the driver. So basically it transforms it and get both signals in phase with each other. It's so simple, right? Yeah, I wish it was, but it's not. So let's keep moving. Pay attention. A transmission line works differently from a sealed box or a ported box, okay? Because those boxes work more like a spring, okay, for the cone of the drivers. There's like reflection, especially on the sealed enclosure, okay? Because there's contained air that moves inside of the box, even on a ported design. So the thing is that a transmission line works a little bit differently because there's no back pressure on the driver. The air travels through this long path which helps control the energy and the sound output, okay? A good example would be a waveguide. I don't know if you guys are aware of a waveguide, right? But you remember when you're talking to a tube and someone listens on the other side and the sound gets there with a little delay. Remember that? So we have this tube, which is the line, the transmission line. And we use usually absorbent material, damping material to control the air inside. So at the end, it helps with reflections and resonances and the audio output through the port, which is the line. And so we got like a more smooth, articulated bass response through the port. I guess that's it. I'm starting to get confused. Let's move on. The thing is, you might not see as many transmission lines as you see ported or sealed boxes. Why? Because it's complicated and we're here to try understand the basics. But the thing is, there are no transmission lines in the market. There is. Guess what? They're complicated, they're more expensive, more material, more time, more science, more development phase or whatever. And the thing is, a ported and sealed designs work great actually, and they're less costly, so that's why we don't see many of those in the market. It's more for us like do-it-yourselfers and like home builders and like curious designers that want to get into know all of that. and make our own. What are the advantages of a transmission line? Well, first the slope. The roll-off of a transmission line box is pretty close to a sealed box. 12 dBs per octave. So I mean it's more like a smooth roll-off after the resonant frequency. So it rolls off at 12 dB per octave. That's good. Transmission lines are known to be very good in the mid-range as well, because there is no build-up pressure behind the cone of the driver. So the mids are known to be more natural. Lower frequencies, you guys know, the rear radiating air moves through the tube, reinforcing the bass. And usually what happens is the FS of the driver even drops a little bit. So the air in the transmission line loads the bass driver, lowering the resonance frequency. So at the end of the day, the driver have less cone excursion. We save on cone excursion, which is, it might be a problem, especially in a vented design where the cone like gets crazy sometimes. That's something that we pay attention on ported designs, so we have better driver control. Another advantage that they say, it's the positioning in room. So they're less sensitive to positioning the speakers, meaning they're easy to work with because they're known to have a better spatial. They're known for having a better spatial, I'm trying to say spacious soundstage. Okay, let's think about how to start your own transmission line. It's not that easy, guys. First of all, if you wanna like design your own transmission lines, I suggest you guys start studying transmission lines. Get acquainted to transmission lines. Get like familiar with transmission lines. Get to know the principles, options, designs, and functionality, and softwares and calculators, okay? I mean, you don't need to be an engineer or a mathematician, even Albert Einstein, to understand the principles and to make a transmission line. Don't worry, guys, let's keep moving. So there are some calculators online and there are some softwares. At first, everything's gonna look complicated. So if you have a friend, if you're part of a forum where you can ask people, please do it, okay? Find your own Neil. So don't worry for now, because I'm gonna post everything you need to get started on the link down below. So there are different types of transmission lines to make it even more complicated. They're like tapered, horn, exponential, conical, straight, or whatever. It's a bunch of stuff. Don't get scared yet. Let's move on. For now, we're going to stick to a quarter wave transmission line, which is a simple design that everyone can start with. And for that, to start with a quarter wave transmission line, we need the length of the wave at the resonance frequency response, as the FS, okay, on theta small parameter. So you get the FS, you get free air resonance response. The length of the line is going to be a quarter of the total length of this wave. It's a simple formula. So we get like a driver that has an FS of 42 Hertz. So I go to our calculator. How to get the wavelength? Oh, come on. We get the speed of sound. I'm gonna use 343 meters per second. So you get 343 meters per second. You divide by 42 Hertz and we get to 8.16 meters. We need a quarter of this wavelength. So we're gonna divide that by 4 and we get to 2.04 meters. 2 meter line on the back of the box. Oh God, how am I gonna fold a 2 meter line? Because remember, we need a specific area. This pipe cannot be just like skinny. For a classic design, we're gonna use the driver's displacement, okay, the cone displacement. So it's gonna be the SD of the driver. So let's say the driver has an SD of 200 centimeters, square centimeters. Okay, that's the area we are gonna use for our tube, our line. So you get 200 times 2 meters. Let's say we have like 20 centimeters times 10 times 2 meters, 400 liters. That's a lot. Anyways, that's the formula. You use your own drivers, okay? So we get the volume by multiplying the area by the length, and we get a big volume depending on our driver. At the end of the day, we have a tube with a specific area for a specific cone, for a specific driver that has a specific FS. And the box is kind of ready, because you know you're gonna get a lot of ripples and notches on a curve response. And that is gonna be fixed with all the damping material you're gonna add, like polyfill, fiberglass, or whatever. But at this time, we're gonna fill it up with acoustic material. And that's kind in a proportion of like for every 30 liters, which is like 1 cubic feet. 1 cubic feet is around 28, but let's say every 30 liters, we add like 250 grams of polyfill, or like this condensed like fiber. So that's a super basic way to tell you guys how to start. Guess what? It's probably not gonna work, because I wish it was that simple. At this point, we need a computer help. We need like a calculator, a software, or something to get this thing going. Because at the end, if we do that, it might work. And we don't know, we have no idea what's going on inside. So a computer software simulates what's happening inside of the box with the damping material, the length of the tubes, the folds, the area, and all of that. Okay guys, I think we had enough. We know everything we need for a transmission line video. So now we're gonna move to Neil's design, okay? Guess what? It's gonna get even more complicated, because it's not a transmission line, it's a mass-loaded transmission line. And I'm gonna define a little bit what does that do according to Neil and our conversations, so you guys get familiar with what are we making. I'm gonna share a little bit of my conversation with Neil, because I want him to explain to you what did he do in his design, even though his website has all the information you need to make those. And this design is for sale on his website with every detail you need to make it. But for now, let's talk about the mass-loaded transmission line. What's a mass-loaded transmission line? Well, it's a transmission line with a load of mass. Let's see what Neil has to say about that. It's a mass-loaded transmission line. And since the entire line is tapered down, it's not the same area, the whole tube. It's called a terminus opening. The end of the port's the terminus. In a typical ported box, the air acts like a spring. And then, when the frequency is low enough, the air inside of the port resonates. In a transmission line, at higher frequencies, the air is not springing. And as the frequency goes lower, more and more of the air inside of the transmission line becomes coupled with the woofer. It actually moves back and forth, and because of the taper, it moves farther and farther. And this is how the air's mass is added to the woofer. So its fundamental frequency is lower than the FS of the driver. I guess we all want that. So to make it short, in a ported speaker, only the air in the port is moving. In a mass-loaded transmission line, all the air between the woofer and the terminus opening end of the tube moves. And he adds up that a mass-loaded transmission line is the closest you can get to an organ pipe. Thanks, Neil. We're gonna move on, because I can't wait to make that and listen to it. Let's go to the website, guys. Move on. All right, guys, so I'm gonna put my hat on. Wow, you're looking good. Okay, I think all my power is in the hat, because I don't know if you guys noticed, but it says Deus. And Deus means God in Portuguese and Latin. God is always in my head. Isn't it amazing? I'm impressed. Okay, recording the screen. Guys, I'm here at Neil Blanchard Designs. Don't worry, because I'm gonna post all the information you need on the link down below. So you go to no big deal, Neil Blanchard Designs, and he has audio loudspeaker plans, audio loudspeaker mods, Neil Blanchard Designs, and we go to shop, and we wait because the garage is slow. This is Neil's website, and we can see here the two transmission lines he was talking about. We have the mass loaded transmission line with the SB Acoustics woofer and SB Acoustics tweeter, and we have it with the SB Acoustics woofer and the linoleum, okay, and the dipole tweeter from Radio Shack. This is another version. It's a different tweeter and it's no longer available. You gotta buy it used on eBay or somewhere else. It's a different sound. He likes it, but we're gonna work on the available version, which is this one. And we go to the shop and we find his speaker designs and modifications here. We are gonna go to MLTL-6, and this is the mass loaded transmission line speaker build manual. Actually, this is not the manual, but I got the manual. And guys, it's detailed, it's all explained, and I'm gonna go through it later. But the thing is, we have a mass loaded transmission line that uses 6-inch paper cone woofer and neither a soft dome tweeter or a dipole tweeter. The speaker has the best bass quality of any speaker I've heard in my nearly 4 decades of music listening. They're essentially flat to about 32 Hz and also wonderful unboxy mid-range. Yeah, that's what we're talking about, the mid-range. And the spacious soundstage. And may rival open baffle designs. I wanna hear that, Neil. Okay, so I have a cabinet of 9 inches by 21.5 by 16, and let's keep moving. Okay, it can be done with MDF or plywood, multi-plywood, okay, like Baltic birch plywood. He can provide the CAD files, so if you have access to a CNC, just get the files, get it cut and do it at home. Guys, he's making it so easy, or not. I have also spent a long time designing and refining the crossover designs. So we have, both versions have a second order filter on a woofer. The 1-inch dome has a 4th order filter and the dipole tweeter has a 3rd order. I used a program called HORNRESP, which is kind of complicated in the beginning, but then you get used to it and just gotta explore it. All right, let's keep moving. Capacitors. All the capacitors and brands and links, everything is in the manual. You have all the links, you can make choices, your own choices, and everything is explained. We have all the crossover schemes, we have all the links, and we have more series crossovers, and we have phase response, impedance response for series crossovers, for parallel crossovers, and for the linoleum, for the lineum dipole tweeter version, we have another crossover, and then we have another series crossover for it, and we have another curve response with impedance as well. We have the CAD models, more details about how to make the cabinets, glue it and brace it and everything we need, okay? But guess what? This is not all, guys. There is more. Those are the plans for the cabinets and it's all here. Everything you need with the cuts on a sheet panel of plywood or MDF. So, Neil, thank you. You're making my life so easy. Okay guys, we have the images here and it's a beautiful speaker. I think I'm gonna stick to the plywood, okay? First because I have a bunch, second because I love the finish of the multi-plywood. New, I might change our design a little bit. I mean, just visually. And you can do that too. Paint it, you can add hardwood and make it look different. Okay, I think we're done, guys, with the technical part. And as usual, I talk so much that I got tired of myself. Alright, guys, so I think we got to the end. I talked so much that the boxes are pretty much ready. Best day ever is over, and I'm gonna have the best night ever. This is just an introduction to transmission lines, okay? And I'm gonna work on other transmission line designs here, okay? I'm gonna make our own design on a camera so you guys can see how does it work. Maybe you learn something like from HORNRESP. I read all the comments. I mean, I try. Sorry if I'm late sometimes, guys, but I'm gonna read and answer. The thing is, you guys ask about crossovers. We're gonna go into crossovers. I don't know when, but I'm gonna make a video about crossovers, or either include crossovers on the next design. Explain how do I make the crossovers, okay? Thanks for your comments down below. Thanks for participating, okay guys? That helps me a lot to like decide what I'm gonna do next, what you guys are interested in, like the crossovers. That's cool. I hope you guys like the transmission lines. I don't know, I've been working with full ranges. I guess you guys are enjoying the full ranges and the transmission lines, which are just beginning. At this point, I'm not gonna show the crossovers or the measurements or the design for this speaker, because this is not my design. I cannot just like open up on YouTube, okay? So you guys can buy his manual, or you guys can access his website. Talk to Neil, he's such a nice guy. If you have any questions, you can ask me or ask him. I mean, I'm here for you guys. I really appreciate all of you guys watching the videos, liking, commenting, subscribing. There's a lot more to come. I'm only one. I don't have any help, so I make everything by myself. I wish I had a website running. I wish I had more videos, more details and more things, but I have plans to grow the channel. I have a lot of ideas, guys. A lot of ideas per second. Sometimes it's too much. I guess you guys are lucky. So this is gonna be video number 1. As you guys were asking for more details, I'm trying to make like 2 videos because it was getting too long. So I'm gonna put all the technicals on video number 1. And on video number 2, we're gonna finish those speakers. It's gonna be all making, woodworking, crossovers, drivers, and wiring, testing, curves, and I mean, whatever is missing. I guess it's missing a lot. Okay. So video number 1 is over. I hope to see you guys soon on video number 2. That might be out in a week. So guys, just wait a little bit. Video number 2 is coming in a week, I hope. Thanks for watching, guys. Don't forget to like and subscribe and comment down below. It really helps the channel, I guess, algorithm, whatever, but it helps me to understand you guys, and we can like develop this relationship. Hope you guys had fun, and see you guys soon. Bye.